Models represent knowledge of how the world works. We've talked about two types of models, sample models and distribution models. In this video, we focus on a concrete example to illustrate the key differences between sample models and distribution models. By the end of this video, you will be able to describe the advantages and disadvantages of sample models and distribution models, and you will also be able to explain why sample models can be represented more compactly than distribution models. Let's consider the problem of rolling 12 dice. This can be done easily with a single die and enough patience. Rolling a single die 12 times is an example of a sample model. Programmatically, one would generate a random number from 1 to 6 12 times. This is very compact and does not consider joint probabilities. Modeling the complete joint distribution of rolling 12 dice is much more work. We must consider every possible outcome of 12 dice and assign a probability to each outcome. With one die, we have 6 outcomes. With 2 dice, we have 36 outcomes. 3 has 216. 4 has 1,296. And by the time you get to 12 dice, we have over 2 billion possible outcomes to consider. But it can be useful that a distribution model produces the exact probability of an outcome. For example, we can compute the expected outcome directly or quantify the variability in outcomes. Let's summarize the benefits of each type of model. Sample models require less memory. Distribution models, on the other hand, can be used to compute the exact expected outcome by summing over all outcomes weighted by their probabilities. Note that sample models can only approximate this expected outcome by averaging many samples together. Knowing the exact probabilities also has the flexibility of assessing risk. For example, when a doctor is prescribing medicine, they would consider many possible side effects and how likely they are to occur. In this video, we described how sample models can be more compact than distribution models, and how the explicit probabilities in distribution models can be useful in some situations, such as for computing expectations.